Hi dear students, welcome back to computer science class. We have already completed data file handling in Python and seen two different types of files like text file and binary file, and of course we have performed operations like read, basic operations like read, write and append, and we have worked on number of functions on read and write. And today we have another very important as well as interesting topic for discussion. It's all about data structures in Python. In every programming language we have the concept data structures, and we have already discussed one data structure, a number of data types and a data structure list. And what is the specialty of data structures in a programming language? Of course, I would say one more thing. It is one of my personal favorites. Just because we can connect all the concepts which we are going to learn here in data structures in real time or to real time or the real world models. Okay, we can directly connect all our examples, all our things, all our concepts to real world. Actually, the concept itself is taken from real world models. So data structure means, how can you define the term data structure? We can see the data structure, the concept in every programming language, because it is very important in every programming language. And you can see the application of these concepts of data structures like stack and queue in most of our daily examples or daily entities, daily working entities, right? Okay, so what actually data structures is? We know in every programming language we have the concept data structures, but the only difference is in its implementation. In C++ we have one kind of implementation, but in Python it is somewhat very easy for us to implement the concept of data structures. And here in this chapter we mainly focus on stack and queue. Two important data structures, stack and queue. Okay, yeah. So what do you mean by data structure? How to define the term data structure? Just reverse the term. Structure data, structure of data, right? Structure of data in the sense how we do store data in a computer or in computer's memory. Okay, or we can say what? It is a logical representation of data in computer's memory. Okay, logical representation of data in computer memory. And we have various data structures. Stack is of one kind and queue is another kind. Okay, stack follows one format of storing and queue follows another format of storing data, storing and processing data. So data structure means structure of data, structures of data. Okay, yeah. So here we can okay, we don't go for much introduction, we can straight to the topic. Yeah. So here is the definition, the exact definition of data structures. Data structure is a way of storing, retrieving and organizing data used for more efficient performance and used to provide optimal performance. We know data structure is a way of storing, retrieving, taking back and organizing data. That's a key point. Okay, organizing data in an efficient way so that it provides us the optimal performance, the maximum performance, right? Yeah. Then several data structures or data types are available in every programming language. Here in Python we have list is a data structure, stack is another, queue is another, and we have a number of data structures. And the specialty is it's a sequential data structure. Okay, both stack and queue both are sequential data structures, and list is also a sequential data structure. We already know that. Okay, yeah. In +1 we have learned list. We know what a list is. List is a sequential data structure or sequential data type or a linear collection of data elements, or we can say what? Linear data structure. Okay, it's a sequential data structure. List is a sequential data structure or a linear data structure. And how we are storing elements in a list? Either manually or either static or dynamic method we can store value. Either you can directly assign the value or you can have it dynamic, okay, as a user input. Okay, then how we are accessing value or how we are referred to the values in a list? Using the concept of index or subscript, right? Using the concept of index or subscript we refer to or access the elements of a list. Index or subscript is just like page number of a book. And here in Python or in any programming language, index starts with 0 and ends with n-1. N means total number of elements, and 0 to n-1, or we can say what? 0 to last -1. Okay, yeah. Then the concept of index or subscript is used to access the elements. Okay, then we know list is a dynamic data structure. Why we are saying this list is a dynamic? Because the elements can be added, meaning any number of elements can be added. At the same time, it can be deleted as well, right? That means the size of a list can be increased or decreased, meaning size is not fixed, size is not constant. Okay, yeah, the size means total number of elements. Okay, yeah, size of a list can be increased or decreased at any time. Okay, or it can grow or shrink. Growing means increasing the size. Shrinking means decreasing the size. That is the specialty of list. We know list is a, that's why we say what list is a dynamic data structure. Then what is a static data structure? Static data structure is a structure having fixed size of elements. Suppose we initializing it with size 5. We cannot add 6th element or 7th element, okay, because size is fixed. Maximum size is 5. Okay, but list is a dynamic data structure. Another important feature of list is it supports heterogeneous elements, right? What do you mean by heterogeneous? We can store different type of elements in a list, different data types elements in a list. Like we can store integer, we can store character or a string, or we can store what, floating type. Okay, so list support different type of elements or heterogeneous elements. These are some of the specialties of list. Then why we are talking about list? It is just because we actually, our chapter is based on stack and queue, right? Stack and queue both are only concepts. Okay, both are only concepts, and through list we are implementing these concepts. Hope you get it. Stacks and queues are simply concepts. Okay, and list is the way through which we are implementing these concepts. I can make it more simple. Just like, okay, think of two competitions. Okay, writing competition and drawing competition. Okay, and through this writing and drawing we are conveying something, some idea, right? Okay, so drawing and writing competition. Actually, these two can be thought of as a concept. Okay, concepts. Writing is a concept, reading is a concept. And how we implementing it? Using our pen, right? Using our pen. So here pen acts as the implementation method, just like list here in the case of stack and queue, right? Here pen acts as list, and drawing and writing acts as stack and queue. Hope you get it. Stack and queue are concepts, drawing and writing are concepts, list is an implementation method, pen is another implementation method. Okay, that is why we have discussed about list in detail. Okay, yeah. So these are the properties of list. We know list is a sequential data structure or a linear data structure. It stores heterogeneous elements, and elements are referred to or accessed using index or subscript, right? And it is a dynamic data structure as well. Dynamic in sense it can be increased, size can be increased or decreased at any time. And as I've told you, our main focus is on stack and queue. Okay, in this chapter we'll discuss concepts of stack and queue in detail, and the operations which can be performed on, and the processing order, all those kind of stuff with some added examples. Okay, yeah. So we can move on to stack. Actually, what is a stack? Just before heading to the topic in detail, I can show you with example. Okay, yeah. Stack is a data structure. We know stack is a simple data structure, and it is a data structure having two operations, mainly two operations: insertion and deletion. Okay, yeah. So just think this as a platform. Okay, stack is a structure having two ends. One end is closed, other end is opened. Okay, this is a closed end. Okay, I have inserted this item as a first element. And where can you insert the next item, the second item? Consider this as the first item. Where can you insert the second item? Just above this first item here, right? Yes. And suppose you are inserting one more item, it can be placed here, right? Yes. So this is the insertion method. You know, this end is the opened end, this end is the closed end, right? One end is open, the other end is closed, and through that opened end you can perform insertion as well as deletion. Right? How can you delete? Which element can be deleted first? this or this, first, second or last, only the last element, right? Only this can be deleted first, and this can be deleted second, and this can be deleted last, right? This is what a stack is. Okay, hope you get the idea. Yeah, then we can look at the points. Okay, yeah, stack is a linear data structure. Linear data structure means, what do you mean by linear? We have two terminologies, linear and non-linear. Linear in the sense we can predict the next item. Okay, here in this case you can predict just after the last element, the first element. Okay, you can predict the second element, you can predict the third element, right? It is stored one by one in the memory, in the computer memory. Data is stored one by one. That means just after one item we can predict what next is. Okay, because it occupies contiguous memory location in computer memory. Okay, that's a concept. In the case of a sequential data structure, it occupies continuous memory location one by one. It is not scattered over here and there. Okay, it occupies continuous memory location or contiguous memory location, so we can predict the next item. But in the case of non-linear data structure, we cannot predict the next item because it may be stored somewhere here and there in computer memory. Okay, that is the difference. We look at only the linear data structure. Okay, stack is a linear data structure, and insertion and deletion are the two main operations which can be performed through only one end. That end is called top of the stack. I've told you this is the bottom, this is the top. Okay, only through this end we are inserting and deleting, right? And that end is called top of the stack. Yeah. Then insertion operation is known as push, and deletion operation is known as pop. Okay, we are performing two operations, insertion and deletion. Insertion is called push and deletion is called pop. Then LIFO. What is LIFO? That is a processing order of a stack. LIFO means last in first out. Last in first out in sense, last input item can be taken out first, right? Last inputted item can be taken out first because it occupies what? LIFO, last in first out data structure. Okay, example, pile of books. I've already shown you, okay, how it works. Pile of books, pile of trays. Yeah. Then here we have two major operations, what? Push and pop. Okay, I'll show you with the help of an example. Here we have an example, stack. Okay, yeah, we know we are implementing the concept through list. Okay, here we have a stack. Initially we don't have any element here in the stack, right? At present we have, suppose we have 4 memory locations. Yeah, we know it is not static, it is dynamic. Okay, yeah. So initially what? The top points to none. It means our stack is empty. We don't have any element in our stack. Suppose we inserting one item, 6. Inserting one item in the sense we push one item. We are pushing one item. So 6 will be placed at the 0th index, right? 0th index of the stack. So top points to 6, right? Top points to 6. And we are inserting one more item. What? A. We know it supports heterogeneous elements because we implementing the concept of stack through list. List supports heterogeneous item. Okay, so we inserting A at the time. Top points to A. Just before this operation, inserting A, top points to 6. After inserting one item just above 6, top points to A. Okay, yeah, it's called push. Yeah. Then we have inserted 3.2. It's another data type. 6 is integer, A is character, 3.2 is floating type. Yeah. At the time, top points to 3.2. Okay, just before top points to A, and after inserting one more item just above, top points to 3.2, right? And we have one more item, that is 6. What? X. Okay, at the time, top points to X. Meaning top will be incremented at the time of inserting item or pushing item. Okay, this is only for what? Insertion operation. Okay, I can repeat. Yeah, initially top points to none because we don't have any element, and after inserting 6, we can insert 6 only at 0. Okay, yeah, top points to 6. After inserting one more item, A is a character type, top points to A. We know top is simply a variable. Okay, top is simply a variable that stores a value, or that contains a value. Yeah. Then A, we can think it of as an index. Okay, top points to index. Yeah, top A. After that, top 3.2, top points to 3.2 X. Top points to X. Okay, this is all about insertion or push operation. What about pop? Yeah, which element can be popped out first or deleted first? Here in this case, can you delete 6? No. Can you delete A? No. Can you delete 3.2? No. Because when you try to delete all these items, any of these items other than X, what happens? It is not a stack anymore. Okay, it is not a stack anymore. Just before implementing or going to in detail of these concepts, just have a concept in our mind. Okay, that is simple. We don't have any default mechanism, or we don't have any default stack or queue or any concept in any programming language. Okay, we are implementing it manually. We are implementing it through our code, source code. Okay, that means we don't have a default stack. We don't have a default queue. Okay, yeah. So we implementing it through coding. Okay, so when you try to delete A, it's possible, but it won't be a stack anymore. Okay, yeah. So you here in the case of a stack, when you are implementing it as a stack, you can delete only X, right? Because you can delete only the element at the top. So what happens after at the time it points to X, right? After deleting or popping this item, top points to which element? 3.2, right? 3.2. It is just reverse operation. Yeah. Now top points to 3.2, right? Yes. After deleting 3.2, top points to which element? A. Meaning these two spaces will be empty. Okay? Because we have already deleted the elements. Okay? Topmost two elements. Yeah. Then after deleting A, now top points to A, right? After deleting A, top points to 6. And after popping 6, the stack will be empty. This is very simple operation. What going reverse, right? Yes. Okay. Can you tell me another example for stack operation? Or undo operation, right? Undo operation is just like this. Yeah. We are going from one page to another page, another page, another page, another page. When you undo, comes to previous, 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 and previous. That's it. Okay. This is what exactly happens in the case of at the time of browsing, right? Yeah. So we are coming to it. So we perform two major operations on a stack: push and pop, and we have seen the example. Okay, we have seen the working through our example. Yeah. Then declare variable top. We know top is a variable. It points to the topmost element or to the index. Okay. Yeah. Then stack is a dynamic data structure. We know that. Here in the first case it is empty, and after inserting 6, it increases size. Right. Then after inserting A, one more item, it increases size. The same way it can decrease as well. And after, okay, now we have 4 elements. Yeah. After deleting 4, it becomes 3. After deleting the third, it becomes 2. Right. Yeah. It can grow as well as it can shrink. The size can be increased as well as decreased. Okay. Yeah. Then it's a static data structure. Okay, it's not a static, it's a dynamic. And static data structure means it's having fixed size. Okay. Suppose we are declaring something with size 5. We cannot insert 6th item or 7th item. Okay. It is fixed. Yeah. Then used to reverse the order. Actually, this concept is used to reverse the order. We have seen in the example, in the case of undo and browsing. Okay. Yeah. Then examples. Okay. We are looking at examples of stack operation. The first one is browsing. Browsing on the internet. Okay. Just think of marygiri.com. Okay. www.marygiri.com. Suppose you are going to what? Academics. Okay. Yeah. Going to academics. You have a link, academics. Then you are clicking on that academics, you will be directed to academics, right, to the page of academics. And after, okay, there we have another page, CBSE, okay, and then you will go to CBSE, right. Then from CBSE we go to plus 2 curriculum. Okay, now we are what, plus 2 curriculum, right. Then how can you just after, okay, clicking on back, what happens? From plus 2 will be directed to CBSE. From CBSE will be directed to academics. From academics you will be directed to Marygiri, right? Marygiri to what? Academics, academics to CBSE, CBSE to plus 2 curriculum. Then reverse order is plus 2 curriculum to what? CBSE, CBSE to academics, academics to Marygiri. Okay, that's what browsing on the internet is. Browsing the internet is. Okay, yes. Then compilers, function calls. You know, function calls. Suppose main calls A calls B. Which one will be executed first? B. Then it goes to A, then it goes to B, right? Main will be placed first, then A, then B. B will be taken out first, pop first, after that A, then main. Okay, that's what function calling is. Then undo operation. Okay, these are some of the examples of what? Stack operation. Okay, so just have a quick revision on this. Yeah, we are discussing about data structure. Data structure means structure of data, logical way of representing data in computer memory. and plus, yeah, it's a way of retrieving, storing, retrieving and organizing data in an efficient way. So it performs, it gives optimal performance. Okay, we implement it through list, and we know the specialty of list. List is a sequential data structure, linear data structure, having elements in sequence, and we have a concept of index or subscript to refer to each location. Then it's a dynamic data structure, what size can be increased or decreased at any time. Then it supports heterogeneous elements. Okay, yes. Then then stack. Stack is a very important data structure. You can see the application of stack in many of the real world scenario or applications. Okay, yeah. Stack is a linear data structure, sequential. Insertion, deletion at one and called top of stack. Insertion is called push, deletion is called pop, and the information processing order is called leaf or last and first. We have 5 specific points. Okay, yeah. Then last, pile of books, pile of trays, stack of coins are some of the examples. Okay, yes. Then 2 major operations, push and pop. We have seen it through examples. Okay, it can be increased or decreased, grow or shrink. Yeah. Then stack is dynamic. Dynamic in sense, increase or decrease, but in the case of static, it is fixed. Yeah. Then used to reverse the order of processing. Examples: browsing. Okay, compiling instruction, then function calls and undo operations. Okay. Yeah. Next we have the implementation of these or operations of stack. Okay, we look at the operations of stack.